Hello everyone and welcome to part two of this series where we make a Parallax scroller in Unity. Um, if you haven't watched part one yet and want to do that, the link will be down in the description. So go and watch that first and then come back here. Um, yeah, so we just start. Here we are in Unity, and this is where we left off in the last episode. So let's see how this actually looks like currently, and then we'll continue from here. Yeah, so as you can see, we don't have any um, infinite scroll, and also you can see that the backgrounds jump around a little bit. So let's start by fixing that first. So let's go into the background object and open Visual Studio where we have the code. So what we need to do, and the reason why this is actually it's not a smooth movement of the background is because we're using the update method, and we should use the fixed update. The update method is not called on a regular interval. There can be at different times between calls, in contrast to fixed update, which is actually called on fixed occasions. I think it's like 60 times a second or something like that. And that if we use that instead and move the background, then it will actually move smoother. So let's test that. So now if I play it again, you can see that now there is no jittering, so to speak. Okay, great. So now we want to make this an infinite scroll, and to do that we will actually use the same sprite but more than one time. So currently we have all the background sprites in the middle, but we will place another copy of each of them, one to the right and one to the left. So we just do that by copying and we paste them twice. I will rename them also. So let's do that. Just calling them 0, 1 or and 2. Like so. Let's do the same thing for the city. 0, 1, and 2. And then we take the bushes as well, which is in the front, and do the same thing. Okay, so now what we want to do is just to place them from left to right. So we start 0, move it to the left. Let's see that it's actually lining up properly. Yeah, I think that would be good enough. So 0 will be to the left, number 1 will be in the middle, and 2 should be to the right. So let's move that away. like this. And check so they line up. Yes, okay, great. Same thing with the other sprites. Move them away. Check that they actually line up. I think that's okay. 1 and 2. All right, just one to go. Yeah, okay. So now we have 3 copies of every background sprite. So what we need to do to make something interesting here is to go into Visual Studio again. And there are a few more things we need to keep track of to actually make this work. First of all, the 3 different sprites have a different starting position, and we need to know where they are. And in total, there are, in this case, 9 sprites, I think. So, and we need to keep track of the starting position of all of them. So we need an array. Let's make that. We need a float array with start pos x. Like that. And then in the start method, we actually need to go through the backgrounds and store the position. So now we will do that with regular loop. And then we need to do that for all the children of this object. So we do oops, got the I here. So now okay. Yes, we need to allocate memory for this array first, of course, also. But it should be the size of the child count, like that. Okay, so first we need to get hold of the actual child transform. So let's do that. Oops. And then we set the start position of for that child equals to like that. So now when we have the starting position, the movement of the sprites should be relative to where they started. So we actually need to change the update that as well. And I will actually replace the for each with this for loop instead, like that. And now what we do is that when we calculate the new background X, we actually add the starting position for that background, like that. Okay, so let's test that and see what we actually get. So now we have the three sprites, the three background sprites side by side, as you can see, but they still don't repeat. So when we come to the end, it's just like before. It's not an infinite scroll, as you can see. So what we will try to do as the camera and the background moves, we will take the sprite that is no longer visible to the camera and move it over to the other side. So and if the camera goes the other direction, we'll move like that. So now we have the starting position, but to know when or where to move, we also need to know the size of the actual sprite. So we need another variable here, and let's call it sprite width. And this one also needs to be initialized in the start method. And to get hold of that, we need to get the component. Oops, get component. If I misspell it, that's why it doesn't want to autocomplete like that, of the sprite renderer. And from the sprite renderer, we can ask for bounds, size, and X. And this will be the width of the actual sprite. Great. So what do we do now? Well, now we need to figure out when to move the sprite. So we need to find out how much has the background moved in relation to the camera. So let's do a calculation of that first. So we have distance to camera, and that should be then the main camera position of x minus the actual position where the background is now. Now, the camera can move in positive and negative direction, and so can the backgrounds, but we are really only interested in the actual distance, not the direction in this case. So let's make this an absolute value. Okay, now we can use this. If the distance to camera is larger than some value, not zero, but um, so as the background on the camera moves, when uh, what can be visible to the camera at any point in time is basically two sprites, the left part of one sprite and the right part of the another sprite. But the sprite that is outside of that visible window, that's the one that should be moved in either direction. So basically, uh, the camera can see uh, basically one. In this case, the sprites are made to be the same size as what the camera can see. Um, so in principle, we could wait to move the sprite to furthest away until it's actually two sprites away. But we could also move it. We could move it as soon as it's not visible anymore. But let's make it 1.5 the sprite width. And this has to be, of course, for this specific sprite. Okay, so now we know that the background we are looking at is not visible to the camera, and we can move it. Which direction should we move it? Well, it depends on which side of the camera it is. If it's to the left of the camera, then we should move this sprite to the right, and if it's to the right, we should move it to the left. So let's check that. And we do that with main camera dot. If the actual position of the camera is greater than the actual position of the background, if it's greater, that means that the camera is to the right of the background, and we should move the background to the right. And that is, we should add a value to it. And we do that by adjusting the start position. Plus equals. I'll misspell it again, like that. Okay. Set X in there as well. Or no, this is not what I call it. I call it start plus X, like that. Didn't I? Let's see. Start plus X, yes. And how long should we move it? Well, we have three sprites. So basically we need to jump over two of the two other sprites and to the so three times the sprite width is how far we should move it. And we need an I in there as well. And this is true here as well. Okay. And in the case that the camera is on the other side, then we subtract 3. So let's see how this works. I think this should be all we need, actually. So let's hit play and we'll see. Okay. I don't understand how I was even able to compile and run this. I forgot to allocate memory for the sprite width, and then things became weird. Really strange. But now, when we have allocated memory, we initialized it with the actual size, and we use that to adjust the starting position depending on where the sprite is in relation to the camera. It works. So that's how you make an infinite scroll. So if we move the game view away a little so we can actually see, oops, no, let's do like this. We can actually see how the sprites are moving if we scroll out. This is it. We can actually see how they are being moved as the camera moves in relation to the backgrounds, or the backgrounds move in relation to the cameras. Okay, great. That was it for this episode or this series, really. The code for this will be available on my GitLab account, and I will post a link in the description below. So if you like this video, please like and subscribe, and see you next time. Bye bye.